So when you see an exponent that is a fraction, okay, this is what it means. This is what a fraction is telling you to do. It's telling you to use the bottom number, which is your denominator. That's going to be the root. So because this example has a 3, this is telling me to take the cube root. That's what that means. The numerator is the power that they want us to raise it to. So a fraction for your exponent is asking you to do 2 things to the base. So the first thing I'm going to do is take the cube root of 8 and then whatever I get, I'm going to square it. So cube root of 8 means what number can I multiply against itself 3 times to get to 8? 2. So because the cube root of 8 is 2, that means I am taking 2 to the power 2. And 2 to the power 2 is 4. So that means that 8 to the power of 2/3 is equal to 4. So number 7, this is saying take the 4th root of 16, and then whatever answer we get, raise it to a power of 3. 4th root of 16 is also 2. 2 to the power of 3 would be 8. All right, any questions about 6 or 7? When you see that, again, there are 2-step questions. First, you have to do the root, and then you would do the power. All right, you had a question like this in your homework that's due Friday now. When you have exponents that are fractions and the denominators are different, the first thing you want to do is rewrite all your exponents with the same denominator. So for question number 8, I have a 2, a 3, and a 6. What do you think my common denominator would be for all 3 of those? So I'm going to write it up here because I know fractions are not our friends. So we got 1/2, I have 4/3, and I have 1/6. So let me do a little fraction lesson real quick because, So if I count by 2s, that would be 2, 4, and you don't have to write this down. I'm kind of going back and doing a little 4th grade lesson real quick. And then if I count by 3s, that would be 3, 6, 9, 12. If I count by 6, that would be 6, 12, 18, 24. All right, what number is in all 3 of those columns? 6. So that means that my common denominator is 6. I need to rewrite all my fractions so that it has a denominator of 6. So if I want to go from 2 to 3, sorry, I just told you the answer. I do that a lot when I'm sleepy. If I want to go from 2 to 6, I have to multiply by 3. So that's what I'm going to do top and bottom. This is going to be times 3. And this is going to be times 3. So that's going to make my new fraction 3/6. For 4/3, I have to multiply it by 2, which is going to make this new fraction 8/6. And my last one already has a 6, so I don't need to change it. So what I have is 8 to the power of 3/6, and then this is 8/6. And now this is 1/6. You have to start by rewriting your exponents. If they're fractions, they need to have the same denominator. And now we're ready to finish it out. So in order to finish it, I am going to add my exponents that are in the top, which is going to give me x to the power of 11/6, and then my denominator is x to the power of 1/6. So now what do I do with my exponents? So we started off by adding what's on top. And now what do I do? What did you say, Denaya? Not multiply. Subtract. We're going to subtract our exponents, which will give me x to the power of 10 over 6. Now, you can reduce your exponents. So 10 over 6 can reduce to what? 5 over 3. This is my answer, but this is not finished. Okay, so now that we have x to the power of 5/3, we're going to write this as with a radical. So that would be the cube root of x to the power of 5. Remember, whenever you're writing, if it has an exponent, the number in the bottom, that's what goes in the elbow. So the 3 goes in the elbow. So now let's finish it out. If I have 5 people, how many groups of 3 can I make with 5 people? Show me with your fingers. How many groups of 3 can you make with 5 people? Just one. So I'm going to take out my x. But I have some left over. Because remember, I'm just going to write this out because I really want to make sure we're doing okay. Because that skills check yesterday, it did scare me. Because I'm like, we got a test. So we're going to just say that y'all was nervous. That's what we'll say. So I have 5 x's. And when I take out, see, this represents my one group. That's my one group. And then left over, I have 2. So that would be x squared. This is the answer that I will be looking for next Wednesday. Notice I didn't say if. When you see a question like this is what I'm looking for.
I have a question.
Yes.
So, why didn't we do the same thing with 6 with the x with the fraction?
We did. Number 6.
Or negative.
Well, it was just one fraction. I mean, it was just one exponent.
I'm saying the way you put the parentheses. Is that the same or not?
Yeah, it's the same thing. Oh, are you asking why did I put the 3 on the outside and not on the inside? Okay, that's a really good question. Thank you for asking that. So we could actually, when it's a number, I usually like to start with the root first. So let's talk about that real quick. We could actually go a different way. We could do 3, we could take the cube root of 8, and then if I put the 2 here, which is totally fine, because you have a choice where you put that 2. Then I would have 8 squared, and 8 squared is 64. And then the cube root of 64 is 4. So 2 different ways to get there. Now 16, if we take 16 to the power of 3, that's a big number. So I personally usually simplify the denominator first and then do the power when it's a number. That's a really good question. Thank you for asking that. All right, just a few more questions and we are done with Appendix 10. So I'll give you a moment to copy that down. Then I'm going to write a little note because you may not remember what to do with a negative exponent because we haven't had that. There's a couple things, but if you just have a negative exponent attached to a base, we just flip the base. So I'll give you a moment to copy that down and then we'll go through it. so when we look at our first one, see how the exponent on the outside is negative? So the first thing you want to do is flip. So what I'm going to do is I'm going to flip that 9 over 4 and make it 4 over 9. And what that does is it just makes the exponent positive. So now that's a positive 5/2. So now we're going to do the exact same thing we did for number 6 and 7, except we have two different numbers. So what this is telling me to do is take the square root first and then take that answer to the power of 5. Now you could take it to the power of 5 first, but then if you could do 4 to the power of 5 and then take the square root of that. But again, when it's a number, I usually start with the index or the root. So we have, well, I guess you don't need parentheses anymore, actually. Okay, so what we have is the square root of 4, and we're going to raise that to the power of 5. And then I have the square root of 9, and I'm going to raise that to the power of 5. The invisible number in the elbow is 2. Let me make sure that's right, though, because I'm trying to remember back to second period, and that was a long time ago. Or is it? Okay. Is that the word of the day yet for Wordle? That's what I get. That's the answer to number 9. All right, how do we feel about number 9? Do we understand the process? Do we have any questions about it? Nobody asked questions, but again, that skills check was a little icy. So, we got questions. We need to talk about them questions. All right, so let's look at number 10. Same thing. I need to flip the reciprocal of -8. It's just -1 over 8. Now, Miss Bryant, do you have to put that negative in the top? No, you don't. You can put that negative wherever you want to. It just needs to be in the fraction. So now we're going to do those two operations. The first thing it's asking us to do is to take the cube root of -1 and raise that to the power of 4. And then I'm also going to take the cube root of 8 and raise that to the power of 4. So who remembers what happens with the -1? Does it stay or does it pop out? Pops out. How do we know it pops out? Because 3 is what kind of number? Odd. Okay. So the cube root of -1 is -1. So what I end up getting is -1 to the power of 4. And then I have the cube root of 8, which is 2 to the power of 4. All right, so this is where we get tricky a little bit. It's the -1 to the power of 4. It's either a +1 or a -1. So raise your hand if you think it's positive. Or thumbs up if you think it's positive. And thumbs down if you think it's negative. I need everybody. -1. Is it a +1 or a -1? It would be positive. It would be positive. And if you want to verify it with your calculator, and so many of you all did this on the skill check yesterday, literally, my heart was hurting. When you put a negative in your calculator and you try to square it, you have to put parentheses around it. For the question we had on the skills check, it was -5 squared, and so many of you all you wrote it like that, and you typed it like that. That is wrong. You cannot do that. You need to have a parentheses around the negative. Please know that as you go off to people's schools. okay? So negative 1 to the power of 4 is positive. 2 to the power of 4 is 16. This is the answer that I would look for. All right, last one. And then we'll do a little bit of graphing. Hopefully you all have graph paper. If not, do the best you can with whatever you have. But who remembers what the power law tells you to do when there's an exponent on the outside? Do we add them, subtract them, or multiply them? Multiply them. This can also be written as the square root of x to the 4th, y to the 8th, and z squared. That's the same thing. So my answer would be x squared, y, 4, and z. And you can get that two different ways. You can multiply the 1/2 to get it. So you're just cutting all your exponents in half. Or you can think about it as far as if you have 4 people, how many groups of 2? If you have 8 people, how many groups of 2? All right, any questions about Appendix 10? So tomorrow, even though homework 4 has been pushed back to Friday, I am going to answer homework questions tomorrow. And those homework questions are on the test. So bring your homework. We'll have time to talk about it tomorrow. Okay, 1.2 intercepts. This is our last part for this test. I forgot to update. I did not update this one. This is not due on Friday. This is due on Monday. It is updated on Canvas. I just didn't update my slide. So homework 5 is due on Monday. I do have some graph paper. I have a couple packs of graph paper that was donated to me, but I have 90 students, so I can only give you one piece. Give you one piece for your homework. You're gonna have to fold a hamburger and hot dog and just try to fit it on there, I guess. It's 5 graphs. All right, so these 5 have to be on graph paper. I do take off points if it's not. All right, so let's get started. If you need to copy this down, go ahead, because a big part of this chapter is, well, not a big part, the entire chapter is finding intercepts. So this is how you find an x-intercept if you don't remember. And this is how you find a y-intercept. So I'll give you a moment to copy that down just in case you don't remember how to do that. So if you're trying to find the x-intercept, that means y becomes 0, and then you solve it. And if you're trying to find the y-intercept, x becomes 0, and you solve it. When you see this on the test, notice I said when, and it asks you for the intercept. I need for you to write them as ordered pairs to get full credit. You have to write your intercept as an ordered pair. So for the first one, if it's the x-intercept, you're going to have a number first and then 0. And if it's a y-intercept, you're going to have 0 first and then a number. So we're going to do about 4 graphs. And then tomorrow, we're not going to graph. We're just going to find the x and y intercepts. And that's it. We'll be done. So technically, I mean, you are going to still have like 3 full days of review. I'm kind of questioning my decision to push it back, but we're going to roll with it. We're going to keep it. Hopefully you all use that time to get it right. We do have a skills check tomorrow. I do drop 1. So if you were one of the people who got a really bad grade yesterday, tomorrow is your chance to redeem yourself. And if you don't know, they're already in Skyward. Okay, so if you're not sure if you're one of those people, yeah. Okay, so let's hit it. Let's go ahead and copy down this first one. If you don't have graph paper, you don't have to draw in all the lines. Oh, sorry. I would just draw in an X and Y axis, and then you're going to need to sketch it. Okay, so you can kind of see what happened. The 0, and then you just simply solve it from there. So for my first one, to find my x-intercept, I would add the 6. And then I would divide by 2. So if you wrote x equals 3, you would still get credit. You just wouldn't get full credit because you need to write it as an ordered pair. So as an ordered pair, and it does say that on the test, it says write it as an ordered pair. It should be 3, 0. And that's the answer I'm looking for. For the y, 2 times 0, that cancels out. So all you have left is y equals -6. So that ordered pair would be 0, -6. So we would graph them both. So on my graph, I'm going to put a point at +3 and a point at -6 and draw a straight line. And that's your graph. Now, I will say, if you don't have graph paper now, Chapter 2 is just about all graphing. So, as I stated on the first day of school, I would get a notebook with graph paper. But if you don't want to do that, at least have some graph paper so you can, like, graph. Any questions about A? All right, let's look at B. Let's go ahead and copy down B. Now we have a fraction. Okay, so again, you're just substituting in your zeros, and you do have to solve. So for the first one, I'm subtracting the 8, which gives me a negative 8. And then who remembers, how do we get rid of a fraction? Multiply by what? The reciprocal, yep. So what would be the reciprocal of negative 3/4? Negative 4/3. So I'm multiplying both sides by negative 4/3. So that is going to cause this side to just equal x. And then when you multiply across, because I'm multiplying these, we actually get a decimal, which is kind of ugly. We get positive 32/3. So that would be my x-intercept, which if you were to put that in the calculator, it's like 10.6. So on my graph, because my graph stops at 10, it's kind of off the grid. So my x-intercept is kind of off the grid. So this would be my x-intercept. And then your y-intercept, this cancels out. So you're just left with y equals 8. So you have 0, 8. And that is your y-intercept. And then we just draw our line. All right, any questions? Who remembers this from, I guess, Algebra 2, Algebra 1? Finding the x and y intercepts. Nothing new. All right, just 2 more and we'll be done for today. And you can either work on homework 5 or start homework 6. I do have 1 piece of graph paper I can give you if you need a sheet for homework 5. Feel free to come up and grab a sheet of graph paper. Okay, let's look at C. Negative 4x plus 3y equals 24. I'm going to give you a moment. I want you to try to do this one by yourself. Try to find your x and y intercept, and then we'll come back together in a few minutes. Not bad. That was actually really good. So for our x-intercept, that means that my y becomes 0. So that would be negative 4x plus 3 times 0 equals 24. Anytime you multiply something by 0, it crosses out. So then I'll have negative 4x equals 24. And when I divide, I have x equals negative 6, which should be written as negative 60. I'm going to put a point on my x-axis at the negative 6. And then when we do our y-intercept, that would be negative 4, and then it's times 0 plus 3y equals 24. Again, anything times 0 crosses out. So that would be 3y equals 24, y equals 8, so 0, 8. So if I put a point at 0, 8, that would be here. And when I connect it, this is what, that's kind of, it's hard for me to make a straight line on my iPad, but for you all, your line should be straight. All right, just about everybody who I looked at had that answer. Is there anything that you want me to re-explain before we do our last example? And if you don't want to ask me in front of everybody, you know, 5th period, you have a whole lot of extra time. So you can also ask me at the end of class. If you don't want to ask me during A lunch, you can ask me at the end of class. All right, last one for today. Go ahead and copy down D. Now we have a quadratic. Remember, a quadratic looks like a parabola. So whenever you're graphing a quadratic, it's going to be either a smile or it's going to be a frown. So we have to find our x-intercepts to figure out what is this one going to look like. It depends on where your y-intercept is. Now the method does not change. We're still putting a 0 for y to find the x, and then a 0 for x to find the y. So for my first one, does everyone notice how the x is squared? So what this tells me is that I'm looking for 2 x-intercepts. So I won't just have 1, I'm gonna have 2 because the x is squared. So I have 4x squared equals 4. Divide both sides by 4, x squared equals 1. So x is going to equal the square root of 1. And what is the square root of 1? There's 2 answers, I heard you. 2 answers I'm looking for. So what's the square root of 1? 1 and negative 1. There's 2 answers.
Wait, what did you do with the 4?
I divided it.
Oh, okay.
Yeah, sorry, I didn't write that. I divided both sides by 4, and then I have that. So now let's write our x-intercepts. I have one at positive 1, 0. I have another one at negative 1, 0. So I'm going to go ahead and put that down. And then for your y-intercept, this cancels out. And all I have left is y equals 4. So that would be 0, 4. So these are my x and y intercepts. So do you think this parabola, when I connect it, is it, yes, Abby?
How would you know if it's also minus plus or minus?
Good question. So Abby asked a good question. How do you know if it's plus or minus 1? Anytime you take a square root, it's plus or minus. We just don't think about the negative, but the square root of 9 is plus and minus 3. The square root of 25 is plus and minus 5. The square root is always 2 answers, not just one. Good question. So do you think this is going to be a smile or a frown based off our points? Yeah, it's going to be upside down. So let's go ahead and connect it. And that is it.